assignment here, and again, this is for Chem 30. Okay, so we have carbon plus oxygen is in equilibrium with carbon dioxide. Here's the KEQ, which we'll use a little bit later. So what's the information that we can put into our ice chart? Because we're going to want to use an ice chart here, because it looks like we've got 2 moles of CO2 was placed in a 1 liter flask, so the concentration is 2 molar for the CO2, right? And it says find the equilibrium concentrations of all 3 gases. Okay, so if you want to write C and O2 and CO2 along the top and make your chart, I would encourage that, right? And so we have a column for carbon, one for oxygen, and one for carbon dioxide. Now, are these is this equilibrium equation balanced? It looks like it is. So we have it's a 1 to 1 to 1 ratio, so that's going to be important. So notice that we're okay. So notice that we're starting with 2 moles per 1 liter of CO2. So I'm going to put a 2 there. And because that's all we're given, we can assume that we have 0 oxygen and 0 carbon. Okay. Now the change, okay, so what's going to happen with the change? Well, if we start off with CO2 only, that's going to go down, isn't it? And if we start off with 0 of these 2, those are going to go up. So we know for sure that the signs have to look like this. Okay. Because it's a 1 to 1 to 1 ratio, I guess it looks like the unknown change, because we don't know what the change is, right? So the unknown change is x, and because it's a 1 to 1, they're all going to change by the exact same amount. So we have x's in that second row. And now we can fill out the equilibrium row. So I have x for carbon, and I have x for O2, and here I have 2 minus x. So that's how you fill out your ice chart there. And once you've got those equilibrium concentrations, that's what's going to be really important going forward, right? Because we want to use the equilibrium concentration, so the equation. So KEQ is going to say this. Remember, we have to have CO2 on top because it is the product. So we're going to have CO2 on top, and underneath we're going to multiply by the concentrations of C times the concentration of O2 there. And they're all to the power of 1 because those are the coefficients. So this number is now going to be pretty important. All right, let me just make some room here. So the KEQ is actually 3.00, not times 10 to anything, it's just 3. And we have CO2, which up top here is 2 minus x. And on the bottom, we have x times x. Okay? So this is going to be 3.00 equals 2 minus x over x squared. And we're going to multiply that up, so we have 3.00 x squared equals 2 minus x. Now it looks like we're going to have a quadratic here. So this is 3.00 x squared plus x minus 2 equals 0. Okay, and you might want to ask yourself, can I factor this? Can I factor this by sight? So is there can I factor it like this, or do I have to use the quadratic equation? And if you're unsure, you can just give it a test. So this is going to be 3x and x here, because that's what's going to multiply to 3x squared. And is it possible for me to put a 2 and a 1, which are factors of 2, in such a way that we add up to 1? So let's see. Well, it looks like if I do positive 1 here and minus 2, 1 minus it's going to be a plus here and a negative over there. There we go. So it looks like, right, we have 3x squared. We have, oh no, I had that right the first time, sorry. My bad. So 3x minus 2x, right? 3x minus 2x would give us this. So it looks like we have, we could factor it this way. And so I know that 3, this is actually 3.00, but we'll take care of that. That's just for significant figures. We'll take care of that at the end of the question. So this is going to be 3x minus 2 equals 0, 3x equals 2, x equals 2/3. And over here, x plus 1 equals 0, or that is x equals negative 1. Okay, so when we have to use the quadratic formula, or when we factor a quadratic, you're going to end up sometimes with two answers, but you have to look carefully at both answers because usually one of them is not going to be able to be counted. And so if you look at this negative 1, for example, is it possible that we could have a negative 1 moles per liter of carbon and oxygen? And is it possible that after this starts to decompose here, and is it possible that it could be a greater amount, like 2 minus a negative 1? So could we have negative 1, and 3? No. From 0, it can only go up. You can't go down. So this negative 1 is not going to be an answer we're going to be able to use. So what that means is that x equals 2/3. Looks like it's going to be the answer for x. So what are the equilibrium concentrations? Well, let me use a different color here now. So it looks like the concentration of C is 2/3, or 0.667 moles per liter. And that's the same for O2, 0.667 moles per liter. And for CO2, right, the concentration, square brackets, for CO2 is going to be 2 minus 0.667, right, which is going to be, so CO2, that's going to be, approximately, what, 1.33, I guess, 0.33 moles per liter. Okay. So that looks like this looks like what the equilibrium concentration should be. Does that make sense?